So what I'm going to show you here is how to prepare a geometry for a bladder design. So I'm going to start here with this SVG that I have of this octopus. I'm going to simplify this geometry by releasing the compound path and removing the eye geometries. I'm then going to rename this main geometry the bladder geometry, and then I'm going to specify a line that represents the tube that goes inside the bladder. So I'm calling this air tube 4, and this is used to tell the system the outer diameter of the tube. So in this case, it's going to be a 1/4 inch outer diameter. As a nicety, I'm just going to rearrange this artboard so that the artboard fits the components. And lastly, I'm going to export this as an SVG. So the only two geometries that we need in order for us to generate the geometries for a bladder design, or bladder mold, are this bladder and air tube geometry. So what you see here is the Siloseam tool. It has some geometries already in place. I'm going to do Shift Delete to clear all elements from the canvas. Then I'm going to drag and drop our octopus file that we just made. I'm going to select both the geometries, and then I'm going to type 1, 2, and 3. And what this does is it generates all the necessary geometries to make a mold for our bladder design. You can switch between 1 and 3 to see two different views, the outline view and the stylized view. I'm going to switch back to the outline view and download this file. And with this, we'll have everything we need to make our 3D model. I created the 3D model using Fusion 360. You'll notice that we have a base geometry with two stepping walls. So I'll refer to that as a step and the main wall. So to begin with, what we do is we hit Insert SVG, and I'm going to select that file that we just made from the Siloseam tool. Then I'm going to specify 1.33 scale. This is a bug in Fusion 360 when importing SVGs. First, I'm going to make the step wall geometry. So I select the registration site and I extrude by 2 millimeters. Then I'm going to get this outer wall and I'm going to extrude by 4 millimeters. And lastly, I'm going to select all the geometries except the bounding box. And lastly, extrude this by -2. This will form the base of the mold. And so once we extrude that, you can see that this mold has 2 levels, and we're going to be using that to create our final bladder geometry. The last step here is I'm going to export this as an STL. I'm going to call this mold, and we're going to 3D print this and make our mold next. So once we have our design files, we're ready to 3D print our mold and separator. We're then going to pour parts A and part B of the silicone system, in this case EcoFlex 0050. I'm then going to use a metal spatula to carefully mix and incorporate the two reagents. I'm then going to position my mold in front of me and carefully pour the silicone mixture into the mold, trying to get into every nook and cranny up to the parting level. We're then going to speed cure this for about 3 minutes at 135 degrees Fahrenheit. And then we're going to take the separator, and using 2 tweezers, we're going to place it in the center of our mold. You can use one of those tweezers to anchor it in place. Finally, we're going to pour the remaining silicone mixture over the top to form the sealing layer. This last step requires a full cure. It takes about 15 minutes at 135 degrees Fahrenheit. Then remove the silicone bladder from the mold and proceed to inject it with water. This is in order to dissolve the PVA that is inside the bladder. It sometimes helps to move and agitate the mixture, but in the end we found that heating it actually helps dissolve the PVA much quicker. Once you're done, insert an air tube and inflate.